Stormwater is the #1 cause of water pollution in urban areas, and it's the only source of pollution that continues to get worse. Every year, 25 trillion gallons of stormwater runoff pours through our streets, parking lots, and roofs. As it flows through our cities, it picks up pathogens and pollutants, contaminates our waters, and overflows our sewers.
That's bad enough on its own, but the economic costs are even worse.
The city of Austin, Texas has a stormwater budget of $100 million a year. The city of San Francisco has a stormwater budget of $40 million a year. Their wastewater O&M budget is $180 million a year. That's $500,000 a day these cities are spending managing stormwater and wastewater.
A lot of these systems are really, really old and they're above capacity. So we don't have a way to effectively address the issues with these systems right now.
And stormwater costs are only going to increase.
The fact is that we're dealing with a lot more water and a lot more people, and we need to upgrade our systems to deal with that. And in order to do that, we have to be able to understand which ones are working and where the failures are, and then fix those failures first.
So we decided to help. I came up with StormSensor to allow cities to intelligently manage their wastewater infrastructure, which means that they can turn stormwater and wastewater into a critical asset instead of a crippling cost.
It's basic expert systems artificial intelligence, real-time monitoring, and predictive analytics for stormwater and wastewater infrastructure. We build our algorithms based on data generated from our patented sensors, and we capture data in real time via the MachineQ LoRa network.
We're also not doing this on a per sensor basis. We're building networks of sensors so you can really see how water moves through these systems by sitting at your desk and watching it happen on your laptop. They can see where the issues are. They can use that information to prioritize big expenditures and green infrastructure projects.
Capturing empirical data, combining it with forecasted conditions, and identifying high-risk areas based on historical events and system conditions give us powerful predictions that help cities reduce future disaster-related response and recovery costs, protect citizens, and design resilient and sustainable communities. Now, stormwater management may not be the most visible or flashy component of the smart cities movement.
It's a hidden aspect. No one's talking about smart sewers, but anything that a city can do to make that process more efficient and save, according to the EPA, between 50 and 90% on O&M costs is huge. And that's what real-time monitoring does. And that's what the predictive analytics will do. It will only further that savings for the cities to operate more efficiently and more sustainably.
So while everyone else in the smart cities marketplace gets their arm around LEDs versus incandescent bulbs and reroutes traffic to reduce air pollution, water problems will continue to surface at an accelerating pace.
And StormSensor is there to solve them.